Welcome everyone, and thank you for joining our session on importing and assessing ridership data with PTV Visum. My name is Carlos Zambrano, and I'm a technical product manager and support engineer at PTV. I joined the PTV team 6 months ago, and I'm excited to be hosting my very first webinar today. It's really great to have you all here. We have made several improvements in how Visum reads and handles ridership data. And today I'll be walking you through how to work with ridership data in the latest version of PTV Visum. So, what is ridership data? Ridership data refers to information about passengers using public transportation services. This data can include details such as where passengers start and end their journeys, the routes they take, the times they travel, and the types of ticket they use. Ridership data is important for several reasons. It helps us in understanding travel patterns, such as how and when people use the network. It allows us to identify areas where demand exceeds capacity. It helps us also in optimizing transit operations by improving schedules, routes, and resource allocation. Ultimately, with ridership data, we can improve the overall efficiency of transportation networks, making them more reliable and effective. This deep dive session will take around 30 minutes, so let's move on to the PowerPoint presentation where we'll discuss the main types of ridership data.
Here is our agenda for today. We have already talked about what ridership data is. Next, we will look at the different types of ridership data. We will then learn how this data is processed in Visum, and we will finish with a live demo using Visum. There are two main types of ridership data. On one hand, we have survey data, which refers to information collected from passengers, providing insights into their travel behaviors and patterns. On the other hand, we have ticket data, which is automatically generated through ticketing systems, capturing information of passenger trips as they occur. Let's take a closer look into each of these. Survey data is collected manually through direct interactions with passengers. In the image, we see an interviewer with a clipboard conducting a survey with a passenger. For example, a survey team might ask passengers a set of questions like, where did you board the train? What is your final destination? What type of ticket are you using? And the interviewer gathers this information shared by the passenger. This method provides detailed insights directly from the passengers, helping us understand their behaviors and preferences. However, there are some limitations to consider. Surveys requires a lot of time, planning, and human resources, and the data collected only represents a small portion of the total ridership. While the interviewer gathers detailed information from passengers, this information is rather uncertain. We don't truly know the passenger's actual journey. What they plan to do and what they actually end up doing can be different, and their travel plans may also change. The other type of data is ticket data. This data is collected automatically through electronic systems, such as smart cards or mobile ticketing apps. For example, in a subway system, passengers use contactless cards to enter and exit stations. When passengers use these systems, the data is recorded electronically, providing check-in and check-out information, meaning where the passenger boards and exits, along with the timestamp. E-ticketing data has several advantages, including the large volume of data collected automatically and its accuracy. So, for example, you can understand the current state of the system without the need for data extrapolation. It is accurate data, however, it is less detailed. In Visum, ridership data are now network objects. This means that they are saved in the network file. Visum creates for each passenger's information a dataset, which can include details like origin destination, departure times, and even user-defined attributes. We will see this in more detail in a moment. After importing the ridership data into Visum, we perform a plausibility check. The plausibility procedure ensures that each of the reported passengers' journeys are plausible and consistent with the model timetable in the network. This procedure uses the dataset's information to generate paths that didn't exist before. Once the plausible paths are generated, Visum can assign these paths to the corresponding network objects, such as links, stop areas, and vehicle journeys, using the direct assignment procedure. This assignment allows us to perform any post-assignment analysis provided for public transport in Visum. It is also important to mention that there is a mutual relation between the ridership data and the generated paths, which means they can reference one another. Some of the benefits of ridership data being network objects in Visum are that there is now a new editable list called ridership data and a clear distinction between input and output data. Ridership data can now carry user-defined attributes. You can also import attribute files using the read ridership data procedure, as well as from a network file, a database, or through the COM interface. Let me show you how these processes look in the software.
So here we are in Visum. This is our famous Halle example. You can see there is a network which consists of links, nodes, turns, and so on. Additionally, the model includes a timetable. The highlighted links represent the line routes we'll be using in this example, which are the tram number 1 in yellow, the tram number 3 in blue, and the tram number 9 in orange. I already prepared the procedure sequence for this session. We'll be importing two types of data. First, system-wide check-in, check-out data, and later on, survey data. Let's start with ticket data. Since ridership data are now network objects, there is a dedicated list for managing these. We can find it under Lists, OD Demand, and then Ridership Data. I prefer to keep everything visible, so I'll place the ridership data below the procedure sequence and rearrange it a little bit. Now let's proceed to import the ticket data into Visum. The ticket data available is in a database format, so notice that we do not use the read ridership procedure in the e-ticket data group. Instead, we go to File, Import, Database. We know beforehand that our ticket data is in a SQLite database, so we select this option, we open the file, and in this next dialog we leave everything as it is, making sure that the option Read Network File Additively is selected. Since there are currently no objects in the ridership data list, conflict avoidance isn't necessary, so we can just leave every setting as it is and import the data. Oops, we are getting a warning. No worries, this is intended for you to see. This warning is telling us that the table ridership data has an unknown attribute. The attribute is called ticket type, and we need to define this attribute as an user-defined attribute in Visum to ensure all data is imported correctly. So for now, we will cancel the import and add the required user-defined attribute. In order to do that, we can go to Network, we select user-defined attributes, and then we have the list of user-defined attributes. We can click on Create, and on the network object list, we look for ridership data. We can click OK, and as the attribute is called ticket type, we can type this in and use it for all the necessary fields. The data type we need is not integer, but text. We confirm with OK, and we have our user-defined attribute called ticket type. We can now close this list, and import the ticket data again from the database. We do exactly the same as before. We go to File, Import, Database. We select SQLite. We select the file. We leave everything as it is. Same in this dialog, we don't change anything, and then we confirm with OK. Now we did not receive a warning. I have prepared a layout for the ridership data list using color coding based on the dataset number. Let me explain what we're looking at. A single dataset can consist of one or several entries. So the index indicates the pathlet key within the dataset. In this example, we have system-wide ticket data, which means there's only one entry or one row per dataset, given that we only have check-in and check-out stops along with the departure time. We also have information regarding the demand segment, the number of passengers, and we can also see the status of the plausibility check. Although we added the user-defined attribute ticket type, it isn't visible in the list yet. To include it, we can go to Select Attributes, find the ticket type attribute, and add it to the list. We have read the ridership data into Visum, which is our input data, so now we are ready to check its plausibility. I will activate the plausibility check procedure, but first, let's take a look at the procedure's parameters. There are three types of plausibility check options we can choose from: survey data, check-in check-out data per vehicle, and check-in check-out data system-wide. Depending on the one we select, the available tabs will update accordingly. For survey data, we assume passengers provided their origin, destination, and any other transport modes they used, though this info might be incomplete. Visum compares the reported journeys with the network timetable to fill in missing details, especially for trips with transfers or walk-in segments. With check-in check-out data per vehicle, every time a passenger boards or alights from a vehicle is recorded. This gives us detailed segments of their journey. Visum uses this data to verify and map their actual paths within the network model. Last, for system-wide check-in check-out data, passengers check in at the start and check out at the end of a closed system. We don't have details about the path between these points, just the entry and exit stops. Visum performs a shortest path search between these stops to estimate possible routes. If you hover over this information icon, you can read more about each plausibility check type. The next parameter we can select is the scope of the plausibility check by status. This parameter is relatively straightforward. Here we selected e-ticket data as our demand segment. So we can choose if all the data will be checked for its plausibility, only the unprocessed data records, or only the unprocessed and unplausible data records. To focus the plausibility check on specific datasets, we can also assign a number to each dataset using the dataset type attribute, and then perform a plausibility check only for a specific range of dataset types. The zones parameter helps organize how passengers' journeys connect within the network. Each trip starts in one zone and ends in another. If the ridership data is incomplete or some stops aren't connected to a zone, this option automatically creates the necessary zones and connections. For this example, we don't need to change this. I want to perform the plausibility check on all data records and select the system-wide check-in check-out data type. Let's have a look at the acceptance criteria type. First, we have the option to consider only active vehicle journey sections for the connection search. Next, under specified departure time, we have the walk time from check-in to the vehicle, which is basically the time it typically takes the passenger to walk from the check-in area to where they board the vehicle. Then we have the allowed departure time windows.
Setting these limits lets the search include vehicles that might leave a little earlier or later than planned, helping to handle real-life timing variations. Last, we have the connection search, and here we can control, for example, how many times a passenger can change vehicles during its journey. I'll uncheck again this option, check again that the general parameters are as I need them, and click OK. Now we can execute the procedure. So there are two things that changed right now. First, we can see that the overall path status changed. Now, each dataset number has the status 1, which is plausible. Secondly, each dataset that was considered plausible has now created a path. So here we can see that paths have been created, but there are only 10 displayed because there is a zone filter in place. We can deactivate this filter by selecting all zones. And now we get 170 paths, which matches our 170 data sets. I also prepared a layout for the PT path list to show some of the interesting information for us. So let me load it. We talked about ridership data and how the PT paths are mutually referenced. We can see this here, as we are reading the dataset number as an indirect attribute in our PT path list. I'm going to enlarge this a bit, and we can sort the list in ascending order. The color scheme we are using here is the same as for our ridership list, making it easy to identify which path was created from which dataset. We can also add the ticket type as an indirect attribute to the list. So we can go to Select Attributes. You can see it is recommended in the Quick Access option, but let me show you where it is. We scroll down the list and find ridership data. Here we can use the first value option, since the ticket type doesn't change within each dataset. We select ticket type, add it to the list, and confirm with OK. So, we are now ready to run the direct assignment procedure. I will execute the procedure, and based on the plausible paths, the network objects will be loaded. One interesting thing we can look at is the assignment for a specific ticket type. For example, how passengers using the monthly ticket type travel within the network. To do this, we can create an OD pair filter. I right-click on the filter icon, go to the PUT Path tab, and select the indirect attribute for ticket type shown in the Quick Access. Then I type monthly as the value, make sure the filter is activated, and I confirm with OK. We can now see how people using the monthly ticket are traveling within the network. It's very simple, and you can also combine conditions in the filter using the OR option to look at two ticket types, for example, monthly and yearly. I will deactivate the filter, and now let's move on and import the survey data we have. I will deactivate our e-ticketing data group to avoid mistakenly rerunning the procedures, and activate our read ridership data procedure for our survey data. This time we will read the data from an attribute file. But first let me change the demand segments to survey so we can better see what happens after each procedure is run. Let's check now the procedure settings. I right-click the procedure and click Edit. So we are now in the Basis tab, and here we have different options which are mostly self-explanatory. First, we have the Delete Ridership Data option. This setting lets us decide how to handle existing ridership data before importing new data. We can keep all current data, delete only the data related to the reference demand segment, or remove all existing data entirely. Then we have conflict handling. This setting manages how to deal with conflicts if the incoming dataset number already exists in Visum. We can choose to ignore the new dataset, override the old dataset, stop the process, or create a new dataset with a different number. We didn't check what dataset numbers are in the attribute file we are about to read, so to ensure the data is imported without any data loss, I will select this last option. At last, we have the protocol file option. This option specifies whether to create a log file documenting the process of reading ridership data, including start and end times and step-by-step details. This log can be useful for tracking the procedure details, but isn't always necessary. Let's move on to the Attributes tab. And here we basically see the table from our attribute file, which has the column names needed for Visum to read the information correctly. We also see that our previously user-defined attribute ticket type is recognized in Visum since the column name is the same. However, there is a new attribute in the table that is not defined in Visum. We can simply click on Create User-Defined Attributes and it will be automatically added in Visum. We can then confirm with OK.
Now we are ready to execute the read ridership data procedure. And we got our survey data.
As you can see, we have a bit more detailed information with the survey data. We have the boarding stop numbers, which is where the passenger boarded the transport system. We also have the input stop number, which refers to the stop associated with the departure time. If there is no input stop given, the boarding stop is used as the input stop. And the alighting stop numbers. But we also have information on the line that was used, along with the corresponding transport system. We can select whether the index is a survey leg or not, and we can also see the ticket type. The same way as before, we can add the user-defined attribute occupation to the list. For this type of data, we can have datasets with one or more rows. Let's have a look at dataset 173. This dataset number has 1, 2, and 3 entries that belong to it. We can use a synchronization and see the first entry in the network editor. What we see right now is a straight line connection between the boarding and aligning stops. Here we see the survey path leg. Stop number 72 is where the passenger boarded. Stop 76 is the input stop, which refers to the departure time. And stop 18 is the alighting stop. And then we can see the last part of the journey, going from stop 18 to stop 10. Index number 2 is the path leg where the data was collected, so we could say it is rather certain. Index 1 is the preceding leg, and index 3 is the succeeding leg of the paths. As a consequence of the ridership data being network objects, we can now also add a dataset manually. To do that, we can simply click on Create, and an empty dataset is added to the list. To add a path leg, we can right-click on the dataset and select the option Add Entry for Dataset, and we would then have a dataset with 2 indexes. We don't need this second entry right now, so I'm just gonna delete it. Let's fill this dataset with some information. We board, for example, at stop number 53. Our input stop number is also going to be 53. Here I will type the number 1 as we are not using a calendar. Let's say the departure time was at 7:14 a.m. and we want to exit at stop number 50 using the same tram number 9. When you give a survey line, the transport system information is filled in, as the survey line is associated with it. I'll mark this entry as the survey leg and I'll just copy the ticket type and occupation attributes. So we added our dataset. Now we are ready to run the plausibility check procedure, but let's have a look at its settings first. The general parameters are the same as before, but this time we select survey data as our data type. In the survey leg path tab, we can select if only active vehicle journey sections are regarded for connection search. Then we have the survey line option. With this, you can specify how strictly Visum matches survey data to network lines and line routes when searching for corresponding time profiles. For this example, I will leave the No Different Line or Line Route Permitted option selected. As before, we have the specified departure time. Here we selected a maximum allowed deviation of 3 minutes, both forwards and backwards. We have again the connection search option, and this last option can be used to enforce transfers before or after the survey path leg, based on survey data indicating that boarding or alighting took place at specific points. Let's go to the next tab, preceding and succeeding part. Here we can also choose to consider only active vehicle journey sections. With the preceding succeeding line option, we can specify how strictly Visum matches survey data to the preceding or succeeding lines and line routes. With the departure time, we can control whether Visum considers or ignores the departure times specified in the survey data, enabling us to define acceptable time deviations or maximum transfer wait times when matching connections. And with the connection search, Visum can search for alternative connections in the network for preceding or succeeding path legs when the specified line routes are not found. At last, we have the Output tab, where we can generate result and protocol files. I will make sure survey data is selected and leave all settings as they are. We can now run the plausibility check procedure. We can see that only paths up to dataset number 175 were created. If we go to our ridership data list and look at datasets 176 and 177, we can see that both were considered unplausible. Let's take dataset 177, which departed from stop 53 at 7:14, and check why it is considered unplausible. The vehicle journey number in which the survey took place was 3821. We can also see this in our concatenated path legs. So, let's find this vehicle journey. We are searching for the number 3821. We do not want links, we want vehicle journeys. Now we can right-click it and open it in the graphical timetable. The vehicle journey is marked in red. We're looking for stop 53, and we can see that the departure time is at 7:18. In our plausibility procedure settings, the maximal deviation was set to 3 minutes. As the departure time for dataset 177 was at 7:14, the dataset is considered unplausible. We can now close this window and let's go ahead and edit the plausibility procedure. I'll edit the backwards deviation to 5 minutes to make it a bit less strict. In the general parameters, we can now also select the option to only check unprocessed and unplausible data records. We confirm with OK and run the procedure again. Now our datasets 176 and 177 are plausible, and a path was generated for both of them. Let's add the occupation user-defined attribute to the list. The quick access suggestion knows exactly what I'm looking for. We add it and confirm. We can now run the direct assignment for the survey data. But first, let's have a quick look at the procedure settings. In the Basis tab, we can, for example, recalculate the demand metrics for the selected demand segments based on the path volumes. We can calculate the selected scheme matrices. We also have a zone selection. Here, we could restrict the assignment calculation to specific origin zones or OD pairs. And with the last setting, we can define the time period for the assignment so Visum only considers paths with departure times within this interval. In the Scheme Matrices tab, we can specify which scheme matrices to calculate during the assignment, for example, the journey time. I won't change anything, so I will just cancel. And now, I'll execute the procedure. Our plausible paths from our survey data have been successfully assigned to the network. So we can see the assigned volumes from our survey demand segment represented in purple bars. We have read, plausibilized, and assigned our survey and e-ticket data. Now we are ready for some post-assignment analysis examples. I prepared a layout which shows a pie chart with the boarding, transfer, and alighting information per stop. I'm gonna load it. And it's a bit tight in here. Let me close some windows to better see the network editor. And here we are. What we see are scaled pie charts for each stop with the passenger volumes. We can easily identify the stops where there is a lot going on. Stop number 18 is the biggest one, which could make sense because it is the city center. The yellow part represents the volume of passengers alighting, which is apparently high. But where are these passengers that exit at stop 18 coming from? We could perform a flow bundle analysis to get that answer. For that, we go to the menu Calculate and we select Flow Bundle. We now select this option, and here we can select the demand segments. We want both e-ticket and survey. We don't want links, we want to select stops. We select stop number 18. In the conditions column, if we click on passenger types, we can select what exactly do we want the flow bundle to show us from this stop. Here we want specifically the destination alightings, so we can uncheck the other options and confirm with OK. We can now execute the flow bundle, and as a result, we can see where the passengers that alight at stop 18 are coming from.
That's it from my side. I hope you enjoyed this session as much as I did and discovered some useful elements to incorporate into your daily work. By the way, there will be a new ridership data example available in the upcoming service pack that replicates everything we have covered today. Make sure to check it out. If you have any questions, feel free to drop them in the chat now or send us an email later. Also, don't forget to check out our upcoming deep dive sessions for more insights into our products. Thank you for your time and have a nice day.